When we look at productivity, it's important to identify the bottlenecks. And so when we talk about bottlenecks, we need to talk about the theory of constraints. The theory of constraints is an approach to dealing with the bottlenecks in your production process. So bottlenecks are things that limit the amount of workflow through your production process, or they're the thing that limits your ability in terms of the amount of a good or service you can provide. So when we talk about the theory of constraints, this theory comes from a book called The Goal by Eli Goldratt. And many operations management courses actually require that you read the book. We don't. But if you ever check it out, it is an interesting book. And this book talks about Eli Goldratt's experience as he was looking at the operations management of a factory. So he was called in as a consultant to look at how well this company was operating. And in the book, what happens is he's thinking about bottlenecks and how to deal with them. And at the same time, he's on a hiking trip with his son and his son's Boy Scout troop. And as he's hiking along, what he realizes is one child in the group, Herbie, is holding everybody up. So everyone that's in front of Herbie is way down the path. And Herbie's the slowest one in the group, so he's holding everybody back. So the second half, everybody who's behind Herbie keeps bumping into him, shuffling along, and is limited to the speed at which they can walk. So Herbie is this bottleneck. And the question is how do you deal with the bottleneck? Well, let's imagine that we were all standing in a line, okay? And that each one of us had a different number between 1 and 10. And the number on that card in your hand tells you how many counts you must do before you take a step. So if you have a 1, then you would count to 1, take a step. Count to 1, take a step, and keep going. If you had a 9 or a 10 in your hand, you would have to count all the way up to 9 or 10 before you could take the next step. And so what happens is you become the bottleneck in that system because everyone behind you who has much lower numbers in their hand are going to keep bumping into you and waiting for you to move. Those with lower numbers that are in front of you have left you long behind, but you're holding everyone back if you have that bigger number. So you're the bottleneck. The bottleneck drives the pace of production. We can't go any faster than the bottleneck. We can't make any more goods than the bottleneck can make because it's what's limiting our ability to produce. Now, how do we fix this? Well, Eli Goldratt had an approach called the theory of constraints. This is a finite scheduling approach that's going to concentrate on scheduling the bottleneck. So there's some key philosophies for how you schedule your production, how you design your process, taking into consideration the bottleneck. So the first thing is we're going to look at the flow of work through the system instead of trying to balance the system. So really we have to take in this bigger picture and the impact that that bottleneck has on the overall flow. So you might have in your production process, let's say you have 3 steps. And the first activity can handle 100 units. Seems we have some technical difficulties here. Can handle 100 units. The second activity in the process can only handle 20 units. And the third activity in the process can handle 100 units. So if we were doing some value stream mapping, we could look at how that inventory flows through. Now, notice that we have a bottleneck. That bottleneck is limiting the amount of material that will flow through the process. Well, if we are focusing on the flow of work through the system, then we need to focus on what's happening with the bottleneck. We want to spend as little time as possible on non-productive activities. So if there's other activities that are involved in doing this, then we want to reduce them as much as possible. We don't want to have our inventory sitting and waiting because we never want this bottleneck to be idle. This bottleneck should always be working on something. And it should be the focus of any improvements or automations we make. Because if we improved activity A, it doesn't do us any good, because if this goes from 100 to 200, we're still limited by the fact that the bottleneck, step B, can only handle 20 units at a time. So we really need to focus on that bottleneck and how we can make sure that bottleneck is constantly going, and how do we keep too much inventory from stacking up, waiting for that bottleneck. Because you can imagine that if part A can process 200 units, then there's going to start being this huge pile of work in process right in front of the bottleneck. So how do we do that? Well, there's some things that we can do about it. And one of those things that we can do about it is this process called drum buffer rope. So let's go back to us walking in a line with the numbers in our hand. Okay? The bottleneck sets the pace. If we're all moving at a different time, because one person has a count of 1 and somebody else has a count of 2 and somebody else has a count of 9, so they're barely moving, then we're all just bumping into each other. But if instead we use the bottleneck as a drum to set the pace of production, then think about it as the person who has the 9 or 10 in their hand. If they clapped every time they moved, then everybody throughout the line would know when to take a step and we'd stop bumping into each other. So we could help smooth out this production process by moving our inventory at the pace of the bottleneck, instead of having it just stockpile in front of the bottleneck because the steps in front are so much quicker and the bottleneck is holding us back. Now, we do want to have some excess inventory in front of the bottleneck. That's because your bottleneck should never be idle. You don't want that bottleneck, which is setting the whole pace of production, to ever just be sitting there and doing nothing, because then you're slowing down everything. That bottleneck should always have something to work on. So if this is our production line here, we should have a little bit of a pile of inventory so that bottleneck is constantly working on something. If we can improve the bottleneck, if we can make it more efficient, then that's where we focus so that we can get that number higher. But if we can't make it more efficient, then we need to focus on how we are moving our inventory through the system based on what's happening with the bottleneck. So we're balancing the workflow through the system and focusing on what's happening with the bottleneck. There's some other things that we should know in terms of this theory of constraints. We have what's called a rope. And the rope is some kind of communication signal that tells all the processes upstream from the bottleneck when to begin production. So the idea is that we can then pull all that inventory through based on what's happening with the bottleneck. So any excess inventory in front of the bottleneck, we want just a little bit so the bottleneck is always working. We want to make sure, though, that when we time the start of any of the production processes, it's taking into consideration when the bottleneck is going to need it. So we said we need to identify the bottleneck. And then as we look at scheduling our process, so we had, this is our process here, we need to do what is called forward scheduling. So we need to look at when we're going to start producing our product and how it's going to impact this bottleneck. We need to make sure that we forward schedule so that we start and create a little bit of a pile in front of the bottleneck so that the bottleneck is always working. But we don't want to forward schedule so there's too much ahead of the bottleneck because we don't want it to be a huge stockpile. We also need to backward schedule. We need to go the other direction. And we need to consider all those steps that happen after the bottleneck and how they're going to be impacted by the limited number of units coming through. So what can we do with those steps in the process so that as soon as the bottleneck is done making those parts, the next step is ready to work on it. So we want to make sure we sustain that bottleneck. We want to make sure we schedule the jobs first whose lead times are less than or equal to the bottleneck processing time. And so we want to make sure then that material gets to the bottleneck when it needs it. The other thing is we look at how the material goes through the process. We want to transfer in batches that are small. We want to transfer in batches that are smaller than the process batch size. So if we are moving small amounts of inventory through, then we're continually moving the inventory, and it's not just 200 units piling high at the first activity and then it can't go through because the bottleneck can only handle 20 units. The idea is that we make the quantity we transport smaller than each machine or activity can process, and that way the material keeps moving as opposed to just sitting as work in process. So really the key here is that we need to identify the bottleneck because it impacts productivity. It's what's limiting how productive we can be. We need to figure out what it is, and we need to schedule accordingly so that we have a nice steady flow through the process, through that bottleneck. And if possible, we want to improve that bottleneck or find an opportunity to do what is called parallel processing. Parallel processing is when you identify the bottleneck and whatever machine or process that is, you get two of them. And that way, instead of being limited to 20 units through the bottleneck, we can now do 20 at this one and 20 at this one. And so in the first activity, we can put 40 through, split them, and then we could do 40 at the step afterwards. So this allows us to increase our capacity and therefore increase our productivity.